Okay, so this evening we're proud to present our own Ted Larson, CEO of Ologic, doing the presentation on product development. As I understand it, this is a presentation, it's a highly regarded presentation he gave it at RoboBusiness, so we're so proud to have him. First off, let's do some industry news. Is there any industry news out there that robotics news that somebody wants to mention?
Yeah, I guess I would have something that would be in that category. NVIDIA has announced the dates of their semi-annual GTC, where they get to talk about all things AI and generative and whatnot, according to NVIDIA, of course. Anyway, you can register that for anything that seems interesting in the period from March the 20th to the 23rd at nvidia.com. And there's actually some robotics stuff that should be of some interest to some folks.
Do you have a link for that? If you could put it in the chat.
Sure, absolutely.
What else do we have for industry news? I've got something that's sad, but NITO's closing. Yeah, robotics is hard.
It was great while it lasted.
It was a good run. Vorwerk acquired NITO in 2017, and it's been a hard slog with Vorwerk's a German conglomerate. They have a lot of other companies, and they actually sell.
Are they liquidating?
Cleaners, which made
Are they liquidating anything that we can like pick up?
Keep your eyes posted. Yeah, you know, at some point they'll be, you know, liquidating the product. The stuff that's relevant to Ross though is the earlier bot vac, not the current model 8, 9, and 10. Okay, the API is different, but I suspect even the earlier models where there's a ton of them available through eBay, you know, price will probably go down on that too. So it's a great Ross tutorial, the bot vac package that is. What I was going to say though is that yeah, Vorwerk, they're closing NITO. They've laid off 98 employees. They didn't renew their lease. They're bringing all the stuff back to Germany. They have a vacuum cleaning company, and they've got their own product of. They've got their own version, Vorwerk version of the bot vac with the LiDAR and so on and so forth. And I suspect they'll keep, you know, developing that and marketing it under their own brand name. We had always done better in Europe than in the United States anyways. And they'll maintain their cloud resources for the NITO product that's out there and parts and so on and so forth for 5 years. But yeah, it was a good run. What else do we have in business news? All right, let's move on to club news. This is club related. It's Robots on Ice coming up February 6th. Now you need to sign up for this if you're going to be part of it. Otherwise, just go and check it out. You'll see people out there that you recognize. I'll put a link in the chat.
Could we have a show of hands here on the Maker Nexus? How many people are going to go to Robots on Ice? I know I am. So only 3 of us. It's a lot of fun, folks. 4? Okay. Oh, what? Okay. It doesn't look like we're going to have that good of a representation this time, camp. So anyhow, about 4 or 5 people are coming.
All right, and we've got Robo Games coming up. Now there's something you can participate in. Actually, I'll be in California for that, and I'm going to ship my Robo Magellan robot, and I'll probably bring a table bot too. And I'll put a link in the chat there. Sign up for Robo Games, guys. This is a fun thing. I think it's April 6th through the 9th. And rather than buying a ticket for each day, actually participating, going in as a participant, is less expensive and a heck of a lot more fun. So, there's time, cobble together a table bot and show up and play. And it gets you in for all 6, 7, 8, 9, 3 or 4 days there. And I put a link in the chat there for Robo Games.
Okay. Again, let's see a showing of hands of how many people are going to do Robo Games. Okay. One, two, three. So we've got like 6 or 7 people here have already raised their hands. Now, David Calkin is always looking for helpers to help run the thing. So he'll be popping onto our list and saying, can people help out? And we'd all appreciate it if he would really appreciate it, getting some help. We've always been very supportive of the club. Okay, handing it back to you, Cam.
What else for club news? Next.
Okay, how do I get on the Zoom camera?
Oh, who's talking?
Who has to unpin me?
Who wants to be spotlighted?
Camp, are you running it?
Yes. Who wants to be spotlighted?
Me,
Who's
the
me?
guy with the microphone, the guy speaking with a microphone.
Okay. Is that
Al's
under Ted
iPhone.
Larson? Is that under Ted Larson's name?
Al's iPhone.
Al's iPhone. Let me find Al's my iPhone. There you go, Dan.
Okay, great. The reason I made a point of that is because what I'm here to talk about is membership and signing up. I'm Dan Tuckler. I'm the secretary and treasurer of the club. And so I'm in charge of collecting dues, and we'll be producing badges for the next meeting. So the reason I wanted to make sure I was on camera is because we've got about 25 people in the room. Almost all of them are already members, which is great. Thank you very much for supporting the club and signing up. But you folks on Zoom, I'm talking to you, if you haven't signed up yet, please consider it. It's $10 per family per year. Hasn't changed in as long as I can remember. By signing up, you get some privileges, including voting and attending some of our public events. But mainly what you're doing is supporting the club and showing your good faith support that you really want to be a member of this club. We're trying to rebuild after COVID. We're trying to get the numbers up. So please give it some thought, and hopefully there's instructions on the website and on how to use PayPal to send money in. And as I said, we'll be printing up badges and distributing them at the next meeting, or if you need, we can mail them to you. All right, any questions? secretary@hbrobotics.org will get to me. Thanks.
Thank you very much, Dan.
By the way, we're up to 22 people here now.
Hey, got more people in person than online.
People like this club.
That's great. Okay, any more club news?
Anybody not sign in?
Let's do what I need help with. Is there anything specific anybody, don't get me started. Is there anything specific anyone needs help with?
Yeah, I've got something real quick. Let me get my video going. George Taylor, is anybody else out there savvy on propeller, the parallax propeller type efforts?
I spent about 3 years of my life on that, but it's long gone.
Yeah, I have this project going that I have a GPS, a cheap GPS, and very successfully got that to come in with an Arduino. However, trying to run the liquid crystal display at the same time, I ran into timing problems. Well, just it didn't seem to have enough horsepower to run all that at the same time. Well, the propeller chip has lots more capability. So I switched over to the propeller chip, and yeah, sure enough, it zips right along. However, I'm running into a phenomena where the baud rate of the LCD, serial LCD, is different than the baud rate of the GPS. And I've tried, putting things into different program modules, I've tried playing around a little bit with the frequencies. My next step is to take it out in the garage where I can get to my oscilloscope and see if I can tinker with the frequency changes to get the baud rates down right. Anyway, does anybody else play with propellers, chips?
Why don't you put that together on an email and post it to the mailing list?
Okay. See if there's any,
Looking for a propeller head.
yeah, because there's like, how many people are on the mailing list nowadays?
More than
Over
1,000
Yeah, okay, that's
knowledgeable
see.
folks.
okay. Anyway,
I've got a question on the mailing list that's gone on and on about booting Ubuntu desktop on the Raspberry Pi, which I used to have success with. I guess the summary of it is, and you can see a whole slew of email in the last couple of hours on the mailing list. Everybody knows where the mailing list is, right? Get to it through the homepage. But the bottom line is, if anybody out there has a micro SD card and a Raspberry Pi 4, if you would try and download the Ubuntu 2204 desktop and get it to boot on the Pi, I'd like to know that somebody's currently having success with that, because I've had no success whatsoever lately. And I've built dozens of, Pi images and booted Pis, and all of a sudden it doesn't work for love or money. So
I'll volunteer. I guess I did what you just asked for on a Pi 3 about 2 months ago. So it's reasonably current. I think you've got a bad SD card. I've tried 4 or 5 SD cards, and I've got 3 or 4 Pi 4s with 8 gigabytes of RAM. And you can look at the mailing list. It's like I've tried everything. Try it one more time, because 3 months ago I had it going too. It wasn't any problem. You go to the download and you image the micro SD card with disk image writer. You put it in the Pi and it boots. You got your desktop, you're telling it what the time zone is and what the Wi-Fi password is, and you're off to the races. You're talking about the Raspberry Pi app, right?
Yeah,
Well,
yeah. No,
that's
I've used the imager too.
Yeah, that damn thing is pretty good.
And burn it with, I'm getting feedback about the disk image writer and being told to use DD, and I use DD. And Marco, thanks for your help. Incidentally, the ROS discussion group, if you're interested in ROS, this is a great group. A lot of troubleshooting going on, a lot of talking about ROS, and a lot of great Linux commands by Mr. Mike and Marco there. So the ROS discussion group on Tuesday is the place to go if you're interested in ROS, beginners or expert.
Amp,
Yes.
I'm going to generate an interrupt here. Where are you getting your image from? That you're
Ubuntu,
flashing?
Ubuntu Raspberry Pi.
Okay.
Yeah.
It's easy to mistake the AMD image for the ARM image.
I
I know
looked
go
at
to
the
IoT,
image,
Raspberry, ARM, yada yada. Now I can still do the server, but I can't seem to get the desktop, neither 2204 or
I looked at
2210.
the image, and the image at least has valid file systems on it. So that's how far I could test it.
Do you have a Pi that you can try to boot, or is that deep in a box somewhere?
That's in a box.
Okay. Very fine. We'll get to the bottom of it. I know. Okay.
The working SD image drops it in the mail to you?
I'm kind of wondering what the hell's going on with the regular download and imaging, because again, I've done it a dozen times,
Yeah.
and all of a sudden it doesn't work. And so I'm interested to somebody to go to the Ubuntu Raspberry Pi image, download image of micro SD. I use disk image writer. I know there's Escher and some other things that people use. That's fine, but I'm interested in somebody downloading, burning a micro SD card and booting a Raspberry Pi and saying it works for me.
Have you tried it on 2 different Raspberry Pis?
Yes, sir. I've got 3 Raspberry Pis. I've got 6 SD cards.
There's no common element that's obvious.
Yeah,
Hey,
it just
Camp, you're
doesn't.
gonna have to figure this out.
Yeah.
Okay, on the mailing
We'll
list,
talk
okay.
about it on the mailing list. If somebody gets it to work or tries it and it doesn't work for them either, that's kind of what I'm in on
kind of
doing.
display are you using?
What?
What kind of display are you using?
HDMI?
And that works with other.
Yeah, it's
And
booting
who's-
my Orange Pi just fine with graphics and so forth.
You're gonna have to figure this out on your own, Camp.
Yeah, and we'll do on the mailing list. That's fine.
Yeah.
Anybody else need help with something they want to talk about? All right. That's what I need help with now. Moving
Okay,
on to show.
Yeah, a bit of a delay here. I'm interested, I'm sure other people have done this. I'm interested in a maybe like a high level or just like kind of like a 101 on building your own battery packs. I'm getting really tired of RC batteries, and I'm building bigger robots. And I know this is like something you can do, but it also takes like some skill. And I'd like to maybe talk to some people who have done this and without blowing themselves up. Because 12 to 24 volts is like not something to mess with.
Okay. So, post to the mailing list if you can give us an answer on that, on battery packs. So I'm handing it back to you, Camp. Anything else?
Well, it's time for show and tell.
Okay. So we're going to start with show and tell over here. Does anybody have anything to show and tell? Okay.
On. Okay, hi. My name is Jeff Westerinen. I was reading, I don't know, some geeky magazine, and there was an article on all different kinds of robot kits that you can get. And one of them was this thing called the Spider Robot. Spider Robot cost $13. Like, okay, I will bite. So I bought the spider kit and the spider robot, and basically it's an octo walker, has 8 legs, and the thing about it is the kit itself comes with it's just a silly simple little kit, and it comes with a single motor and a little battery pack, and then some very, very clever mechanics. I have to say, very, very clever mechanics that makes this thing all work. So then it's like, well, okay, I need more than one motor to make this into a real robot. So I kind of looked around, and there was somebody suggested that, well, if you get 2 of them and you kind of put them together, is it okay? Okay. If you get 2 of them and you put them together, you have 2 motors. 2 motors means that you can move forward, backwards, and in circles. So that's what I did. I got 2 kits and basically just shoved them together, just like that. And you'd be surprised how easy it was for the mechanics to actually be put together, right? So you can see that there are two motors in there, right? Yeah, okay. You can see 2 motors in there, right? And so then what I did is I just decided to use an Arduino. It just was the simplest thing to do. And then I got a motor controller hat for the Arduino, and I guess it's called a shield. And put that on there, and la la la, and la la la, and I came up with it's just the most dirt simple basic control program. And it just went together. It just went together. Now, here's the problem. If you, hang on just a second. Hold on for me. Okay. So when you guys will appreciate the state that this is in. This is my on switch.
It's homebrewed.
It works very well. Right up until you put it down. So I actually was teaching a class last year in beginning engineering, and I was showing them that this is speed, this is torque. So it actually does do something, and my demo program is that it will go forwards and then backwards, and then it'll try to spin around. And it will actually do it if you're actually, it's better to take the battery out because it's actually a little bit lighter. But anyway, so then the next step is to well, I don't know. So you guys, what do you think? I mean, these are just the dog crappiest, motors, just the little stinky little motors that you get in all the little toys. I just don't know that they would ever have enough torque. I just don't think.
How much voltage is your battery pack?
Yeah, so that's a small that's a 7-volt battery.
7 volts.
But anyway,
Wow.
7 volts.
Wow, that should do it.
And it goes into the motor control. This is a motor controller, and that does all the voltage
Is it
regulation and
Jim?
everything for you.
It's Jim, right?
Anyway,
Your first name is Jim, right?
Jeff.
Jeff?
Jeff.
Jeff,
Yeah.
are you aware of our TableBot challenge?
I am, and I have created actually 2 robots for the tabletop challenge. So the next thing to do is I'm going to put a bracket that comes out like this and goes across, and it's going to be made from the little leftover pieces of plastic that the parts came on. It's going to come out and go out across the front of the robot like this. I'm going to put a couple of just distance sensors on there, just really super on-off distance sensors. And I actually have written the control program, and it will do the tabletop challenge.
All
If I
right.
can make it move.
If you could,
So
Have you-
I'm all set up. I'm all set up to make it work. And so I plan to do this. Then I had this whole torque problem. So not sure exactly what I'm going to do.
You
But
got a
anyway,
month. The 21st annual HPRC challenge phase 1 is March the 29th.
yeah,
So you have more than a month to do it.
have you
yeah, if I'm gonna
considered,
come up with something. So anyway, I just thought that everybody here would appreciate just like shoving something together like this and the wonderful state that it's in. You guys
you-
really appreciate that.
have you considered using hydrogen balloons? Or helium would be better, right? Helium
That's-
balloons would lift it a little bit.
That's awesome, Jeff.
Okay. Is there any more show and tell here at the, at Maker Nexus? Oh, Alex? Okay.
Hello, hi, my name's Alex. I was just gonna show a couple of things that, although I can't demo it right now, this is basically a system to detect the position of a robot within 1 millimeter accuracy. So it's a prototype. Basically, I think some of you might have heard of what we call Lighthouse. Okay, these are basically a system made by Valve for use for games, for what do they call that? VR games. And it projects a laser across the room. And this one can receive it and basically triangulate down to millimeter accuracy in X, Y, and Z. So that's one. I'm still working on it. Although it works, I'm planning to sort of like make a board out of it. Okay, and then the other one is, I think some people were interested in FTM, which is a method for 2 radios to be able to know the distance between them. So this is basically a ESP32, and it can measure the distance between two devices that are ESP32 to get not yet very accurate because of reflections in the room, but on outdoors, it can be very accurate. When I say very accurate, 1 meter out of, let's say, 50-meter type distances. So they're cheap, they're new. That's what they look like. So so it's basically an ESP32 based with FTM. Yeah, it's a new one. This particular one is an S2. They have also a C3 and S3. I'm testing them, and so far the S2 is working well. The C3 not yet. The S3 not yet. So in the past I've been working on FTM or equivalent systems. So to me this is interesting. So useful for robotics.
Any other show and tell here in person? I'm going to take that as a no. So now we're going to hand it back to you, Camp, okay?
All right. What do we have for show and tell online here?
I'm here.
Dee Dee,
Yes.
let me spotlight you.
Yeah, I just figure I'd mention that I'm getting the robots ready for Robots on Ice, as well as I'm invited to the California Academy of Sciences. They have a nightlife thing going on this Thursday, I think from 5 to 10. So these robots are going to be speaking there as well. So, and the robot block party that's coming in April. So I think right now they're talking. I just have to turn on the volume here if I can find it. Okay. Uh-oh.
Who is there? Hugo. Hugo who? You go to the store and I will stay home.
Oh boy. Okay.
Ha 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 ha. Hello, how are you doing?
Okay.
I am doing fine.
So that's what these guys are up to. Just
What is your name?
testing them out
My
until
name is
tomorrow. And that's the show and tell.
What are your robots' names, Dee Dee?
Now we've just been calling them by color. This is a silver in-move and this is the white in-move. I think we have one named Blue Phoenix, but I can never tell which one the kids
Silver and
named
white,
that.
huh?
Yeah.
Easy to distinguish them that way.
Yeah. After a while, I kind of forget the robot's name and just call them by color.
Very fine. Very fine, Dee Dee. Thank you very much.
Okay.
You going to be at Robo Games?
I'm going to be at the robot block party. I'm not so sure about Robo Games. I'll be at Robots on Ice, and I will be at the California Academy of Sciences tomorrow.
Yeah, well, Robo Games goes on for a couple of days, so.
Yeah. I see a question. Do they use Chat GPT? I think these are just using Flight, if I last recall, which is just a text to voice translation. So the kids and I just kind of put in a script, and then we have buttons that adjust what they say. You can pick like poetry jam and hi, or just joking, or who's on first, and knock jokes, and then it has the words on screen that help because sometimes it's hard to hear what they're saying.
Morris Davis, thank you very much. What else we have for show and tell online? All right, well, I've got my normal show and tell, but unfortunately everything's blowed up. I was having so much fun on, gosh, it must have been Monday or Tuesday. It was okay. The Tuesday, I had a full stack smart table going with Loco Joe. That is the bot DAC with ultrasonics and the camera. And all of a sudden the bot vac mapping and navigation went to hell. But I've got a couple of pictures, so let me share those at least. So this is Loco Joe here. Incidentally, I know I keep saying this, my book is coming out this month. It's Homebrewed Robots. I basically tell my Silicon Valley story, and I've got 7 robot projects going from Arduino to ROS with the bot vac. And when I last left off, this is the bot vac navigating around my apartment. I had the bot vac, the ultrasonics, and the camera going there. You see the picture of the video, or the picture from the camera. But unfortunately, that went south, along with my ability to make my bootable micro SD cards on Raspberry Pis. So like Mike Wimble says, robots are hard, right? Any more show and tell this evening? All right, like I mentioned, we're going to have the HPRC challenge next month, and I will be bugging everybody incessantly on the mailing list. Don't take it personal. For the most part, I'm talking to myself, but you have a presentation next month. We're the Homebrew Builders Club, not the get together and talk about robots club. We've got a variety of challenges on our mailing list. Let me put this in the chat, including the table bot challenge, the floor bot challenge, the arm bot challenge. My favorite, run what you brung, where you bring your very own one-of-a-kind homebrewed robot and show it off. And the main goal is to you show up with your robot in some state of finished, okay? And then you enumerate what your phase 2 and 3 goals are, and come back in June and September and get 2 months between to meet those goals. And that's how we do a 3-phase challenge. The challenges there are listed on our homepage. Check it out. Again, next month, you have a presentation to give. So get your robot off the shelf, dust it off, charge it up, fix it, finish it, do whatever you need to do. Everybody needs to show up with a robot next month. Are there any more robots for show and tell before we go into the presentation here? All right. Without any further ado, I'd like to introduce Ted Larson. Ted Larson's the CEO of Ologic. Ologic's a consulting firm, if you will, for a variety of robotics companies. And he gave a presentation at Robo Business about guerrilla product development. So without any further ado, let's welcome Ted Larson.
There we go.
Hi. Okay. I think it's working. Is it working? Can you hear me now?
We can hear you.
Okay. So my name is Ted Larson, and I run a company that actually got started right here in the old Homebrew Robotics Club in early 2000s. It turned into a real company in 2005. I started it with the other guy on here, Bob Allen. Wave Bob. And Bob Bob is the guy on the mailing list who apparently has an awesome shop in his home and so if you really want to move to Gardnerville, Nevada, or Carson City, Nevada, you could own that awesome house in the background. That is a very amazing workshop that he's got there. And I thought it was funny. It was like, it looked staged, that I'm like thinking, that's just Bob's workshop. So anyway, we got started in 2005. The original plan was to try to get paid to do robots and try to design cool things and have fun while we're doing it. And it turned into this huge thing. And here I'm doing it now 18 years later, which that's also hard to believe. So I'm going to talk briefly about a product development strategy that we use every day that is kind of based on the lessons that we've learned over the last 18 years building products. There was a book that was published in the 80s called Guerrilla Product Marketing. It was this idea, I read it back then. It was an idea that essentially using uncommon methods to market your product. And just like guerrilla warfare is using uncommon methods to fight a war, the idea of guerrilla marketing was this idea that you would go out and, spray paint a bus bench or something, or do odd leaflets and handouts. That's that me? Shouldn't be me. It didn't happen by itself. No, it did not happen by itself. Hold on a second. Hello? Okay. There we go. Okay. Okay. Weird audio visual problems. Can you hear me now? Okay. So the idea was go and do uncommon ways to design products. That was essentially the idea. And that's a way that we do it every day. Briefly, this is 2 seconds about me. I've been doing this now for 18 years. I started this with Bob Allen there on the screen. We decided that we would go build robots. And actually it was Bob's idea to go do this. He actually bought a booth at a trade show called RoboNexus and said, hey, we should take some of the cool stuff that we've built together and show it off and see if people want to buy it or hire us to do stuff. And the VP of engineering of Hasbro walked into our booth and was like, I like that, I like that, I like that, come work for us. So they were kind of our first big customer. And then we did lots of projects for Hasbro, but then we moved on and did more and more projects for other people. So the idea is that we're a bunch of design engineers with cool product development ideas. We're about 30 people now, actually soon to be more. We're going to hire a couple more people here pretty soon for a project. And then the idea is that we're able to do all the pieces. So we can do like low level hardware engineering, low level like firmware engineering, and then all the way up the software stack to the top. Over the years, we've added additional capabilities. It used to be when it was just Bob and I in the beginning. Bob did all the mechanical engineering, I did all the software, and then we came together and did the electronics together. And nowadays we have a team that does the mechanical engineering and the industrial design work. but our focus these days is still mostly electronics and software. That's usually how people engage with us. They'll come to us for the electronics and software, and it'll turn into something more. So these kind of the core areas that we specialize in: electronics design, software engineering, and then we've gotten really good at design for manufacturing. And a lot of that came out of our early days when we were building products and then have to go to a factory and then work with the factory to get it made, mass produced. And then, so here's some kind of little teasery ones. We have 3 markets primarily that we're serving these days. We still have the consumer electronics toy market. That's never kind of gone away. We did, early projects. One of the ones on here, we did an amp body. He's off in the corner there. You can't see him. He's underneath the video here. I don't know why this wants to. Oh, there we go. Oh, I didn't get rid of it. But anyway, the Star Wars Force Trainer also was another one that we did. That was 2009, so that was quite a ways ago. Oh, I see. Yeah. And so those were early ones that we did, but later on we did this smart baby crib called the SNOO Smart Sleeper. It's a really amazing, it's an infant soothing device for children under the age of 6 months. If you want to learn some interesting things about the SNOO, apparently Business Insider just posted a scathing article on their management that I just saw. They were okay to work with when we worked with them, but apparently they've had some challenges lately. We also worked on Google's Project Tango, which is the phone that does indoor localization and mapping. We were one of the original 16 partner companies on that project. We also did the NVIDIA Kaya robot for NVIDIA. That was their 3D printable robot for the Nano. It was shown off, I guess, in GTC in 2019, just before the pandemic, essentially. And then when we were doing things, we were getting into bigger and larger robotic projects. So some of those projects are, well-known ones. The first one that we got involved heavily in on the large robot side was Willow Garage was shutting down. We had friends that worked at Willow, and they all kind of went out into the world to build new robots, and they knew that we knew how to do electronics in these mobile robots, so they called us for help. So the first one we got was the Relay robot, which used to be known as Savio. The CEO of that company, Steve Cousins, used to be the CEO of Willow Garage. So that was kind of like the first one we got. And then right after that, we got the Nightscope robot. We started doing that one. And then after that, then more and more and more came. So like Cobalt and Simbi. And recently we did Dusty. We worked on the Locust robot. There's just, the list is huge. Like I can't put it all on the slides. I could give a whole presentation on everyone we've done. We've probably designed the insides of over 150 products in the last 18 years. Lately though, we have a new thing that we've been into since just 2019, which is Internet of Things. And we have this partnership with MediaTek on Internet of Things. We evangelize MediaTek's vision of Internet of Things, which is things with cell phone and tablet guts inside of them that are not cell phones and tablets. Okay, that's their vision of Internet of Things. So these would be things like home appliances, connected fitness equipment, weird smart speaker gear. One of the things that started down this path was this product, Angie Hospitality. It's like a smart speaker that lives in a hotel room. You talk to it, and call the concierge by talking to her. It's an Amazon Alexa for hotel rooms, but with no Amazon in the middle. And they have their own NLP engine and everything like that to do their deal. Let's see. Okay, so yeah, here's some robots that we did. We did the bear, obviously. You can see the bear at the Amici's pizza chain. There's one in downtown Mountain View. You can get a bear robot to serve your food. There's a bunch in the restaurants here in the Bay Area that you can see. The relay robots go stay in any of the Sheraton, the smaller Sheraton hotels. There's relay robots in all of them. And they have a deal there. Simbi Robotics, most of their deployments are in the Midwest, but it's like a robot that drives around the grocery store and replaces the guy with the barcode scanner to figure out if shelves are empty. And then Locus Robotics is a warehouse automation robot. Let's see. So now we're finally getting to the product development component of the thing. I figured the robot thing would get people more excited than product development. But here's my basic steps. I got 10 steps, and we're going to run through all 10 steps, and I'm going to tell you some funny stories along the way about the steps. Also too, all of this stuff is documented in a set of Medium articles that I wrote. They're on medium.com. You go search my name. There's 3 separate installments of articles where I go into great detail. And Bob's going to love this because there's pictures in here of stuff that we did back together many, many years ago. So the first thing is planning your product. You've got to plan it, and you've got to come up with a way to figure out how you're going to come up with a plan that you can actually execute on. And the first 2 steps are you need some requirements for your product. And those requirements are usually like, what is it going to do? What things is it going to fulfill? And you need to do that independently of how you're actually going to implement it. So what I evangelize is do not get all hung up in the minutia of how you're going to do it. Think first about the market and the product that you're going to build and what things it's going to do, and then worry about how do you actually solve the problem. So we separated into 2 separate pieces. One is the requirements, and the second is like the specification of what you're going to build. And we have these basic, 4 steps that we do: a concept, design, proof of concept, a prototype, and then a reality. And then here's an example of, simple product planning. One is make a requirements document, write everything down that this thing's going to actually do, and put a stake in the ground and say, this is what it's going to be. Make a specification, like implementation document, where you basically look into, these are the things that I'm going to actually do to implement those requirements and meet them and make them work. And that's the point where you're going to learn when you got a crazy requirement that defies the laws of physics or something, when you realize you can't actually implement it. And then the third piece is you need to collect some user stories about how somebody's actually going to use your product, and go out, interview people that would actually use the product, collect a story of what it would be like for a user to actually use this product. And then at that point, come up with a really basic timeline and a budget for how you're going to plan it. But that's kind of step 1. You got to do that before you can really go anywhere. Step 2 is you really need to take market fit first. So you really need to know, like, if you're going to design a product, go out and do your homework on what the market fit for the product actually should be. And if you don't go out and do this, I guarantee you will fail. Okay. You cannot build, if I build it, they will come products. Those ones 9 times out of 10 fail. I cannot tell you how many products we've worked on where the founders of a company came to us, asked us to design a product. It was really clear that they didn't have their market fit figured out, but they were going to pay us to design the product. So we helped them. But it was kind of like the whole way along the way, I'm like telling them, I'm like, you got the market fit figured out, right? You went out and you actually interviewed people that are going to use this thing, right? It doesn't always work out that way, but you definitely want to get this market fit, and you definitely want to get some help from an industrial designer, because the sizzle sells the steak. You want it to look good when based on the thing that you're going to try to ultimately sell to the end customer. Here's an example of market fit. This is a great story. Okay, so Dusty Robotics. This is a robot that does floor planning and layout on a building construction work site. And when you see the thing go, I mean, basically what it does is you put a floor plan into it. They'll go into a building that has no walls in it. And instead of the guys that get down on the floor with the floor plan and, put the blue tape and the marks on the floor to say where the walls are going to go, you load the floor plan into this robot, and it draws around and prints the walls on the floor with an inkjet printer head. and then they come in and put the walls up. There are all sorts of other interesting things that this thing does, like that makes it so that the building can go up faster. A perfect example being, they didn't know this when they started this, but concrete takes time to set. There's a point where people can't step on the concrete, but the robot could go on the concrete. So you can speed up your building process because they can have the floor plan on the floor before anybody can step foot on the concrete. But my favorite part about the market fit part of this story is they decided they were going to start a construction robotics company. They had no idea what product they were going to pick. They just knew that the market was ripe for disruption because there wasn't anybody building this construction robots in any scale. And so they went out and they had a couple of ideas. One of the big ones they were pushing was possibly a giant Roomba that would clean up work sites. Another one was a burrow-like thing that would drive around and allow you to move materials around on a job site. They did a lot of research on what it would take to build these things and how much the reception might be from the various builders who might actually use them. And one of their market exercises was they were going out to job sites with their construction friends and with trash bags and cleaning up a mess on a work site with trash bags to try to figure out like how much mess would this giant Roomba actually have to pick up? How big would the basket need to be to make it useful? How often would you have to empty it? Those were questions they were trying to answer. And one day they're out doing this and they see a bunch of guys over across the way, down on their hands and knees, laying tape on the ground and taking measurements. And they're like, hey, what you doing, guys? And then they explained it and they walked away and they thought, holy crap, a robot could do this easy. And that is where it came from. So they didn't even build what they set out to originally build. It was based on finding what the market would be and then building a product that was specifically targeted at that market. It's a phenomenal story. But it took a lot of market research for them to come up with this solution. There were months and months and months worth of effort before they ever even began to assemble a robot. So that's a really critical thing. Second one is domain expertise. You need a domain expert. In the case of Dusty, they had somebody who really understood the construction industry. If you don't have a domain expert, you were guaranteed to fail. So let's say that you don't understand a market that you think you're going to go build a product into, and you suddenly have to learn that. The first step you need to go is find somebody that does understand it, that spent a decade or more like doing just that stuff. Don't think that you can watch YouTube videos and become a heart surgeon, okay? Like it doesn't happen. Go get a real heart surgeon to really help you, right? So that's another area too. We've seen products fail where they didn't have a domain expert. And let's see what my sample example is. Okay, so here's Aaron Prather. Okay, he's like the used to be the head guy at FedEx. He was their R&D evangelist, and he has a fantastic. He's always writing all kinds of pundity things. He works at the National Standards Committee now, NIST, doing standards body things on how do you come up with great standards for how do robots actually work well. So like, for example, an example would be come up with a test standard that, you can come up with where you can say, oh, this gripper is reliable or this one is not, things like that. But the one thing that he gets or got a lot of is people coming into FedEx with cool prototypes of things that could unload a truck. Okay. Yet none of them had ever actually unloaded a truck before or spent any time as a truck unloader. I mean, the first thing they should do is go hire somebody that used to work at FedEx unloading trucks all day long for months or years and ask them, what are the problems when you're unloading a truck? How do we make those problems easier? So then that way you've got a domain expert who knows exactly what issues you're going to run into. And he says people will go in there and pitch him all the time these crazy ideas for automated mechanisms for unloading truck or measuring truck volumes or measuring wasted space. And there was always some kind of an issue because they hadn't thought it through because they'd never actually done that job before themselves. So that's important. Okay, surround yourself with awesome people. And that's another thing too is, this is a big concept we have at Ologic, which is nobody works alone. You never want to have that one guy that's the only guy that understands, or gal that understands that one thing, where now they've got COVID and then the whole project's is screwed because the one guy that or gal who had it, you know, is sick. So, and then the other thing is you can't be an expert on everything. So get people that are experts in specific areas to help you. And in some cases, you might have to go outside to find that thing or to find that person. So, you know, I was talking before the meeting about how somebody gave me an eval license for a computational fluid dynamics engine. I'm really getting into thermodynamics for fun. Okay. And like, you know, airflows inside of devices, and how do you get the heat out, and how do you do it with a fan or not with a fan? Okay. I don't have a degree in thermodynamics. If it gets really serious on a project, I'm going to call my friends over at like Avid Thermaloy. They have PhD people in thermodynamics that help solve heating problems. I call them, I get one of their consultants to come in and help me, thermal problem solved. And they've got a PhD in it. So I know they're going to do it right. Right. So, you know, it's fun for me, but, you know, I'm not an expert. So on that. So the idea is surround yourself with that. And then also, there's always some teams too that have somebody that's got like the smartest guy in the room on the team, or some big ego, some narcissistic type. You know, we're always trying to avoid those people to not have to work with them because, again, nobody works alone. Okay. Oh, here's another example of the nobody works alone. You know, and this is, I used to work at HP. I worked at HP in the 90s. I was there when Lou Platt was the CEO, and he ran the place really well until it kind of went downhill later on when he took over. And this is a favorite thing that we do to try to weed out the people that are the tough to work with. Interview somebody for a job and give them an unsolvable problem and see how they react. Okay. If they blame the test, they're probably not a good fit. So, you know, those are things that are generally, you know, things that we like to try to figure out is like, who's a good team player, who works well on a team. It takes huge teams of people to build robots. You all have to work together. There's no possible way anybody can do it alone. So anyway, that's another piece of advice. Number 5, iterate early and often. Failing repeatedly is always the best thing. You want to identify a problem, fix it, and fix it when the cost is low. It's low cost to fix it during that early exercise. It is high cost to fix it after you're producing tens of thousands of it, and you've got to go in after the fact and make a change. Oh, whoops. I think I went too far. Oh, no, that's not right. Okay, here's an example. Okay, so there's an example that comes out of software engineering. I used to be a software engineer before I became a hardware engineer. There's this concept of extreme programming or agile software development methods. This is the idea that nobody works alone. People are working together on a team. You are basically programming in a team. In the case of the software development methods, you're programming in a team. You're going back and forth. You're handing it back and forth. Same should happen in any development process on hardware. You should be working together with another person, handing it back and forth like a hot potato. Somebody else is a little burnt out or needs to take a lunch break. The other person picks it up and runs with it. And these methods work really well for hardware development. And it's funny that, you know, a lot of this stuff, you see this in the software engineering realm, but almost nobody talks about it in the product development realm. And so this is like one of our secret sauces is nobody works alone. We work together. We work in this kind of agile, extreme programming kind of methodology. We take a lot of hints from that. But we don't do it like where it's perfectly, exactly to the spec of how you do it in a book. I guess that's a better. We just steal the ideas. The next thing is, okay, you got to make an MVP. This MVP idea comes from a book called Lean Product Development or Lean Product Development. Yeah, Lean Product Development. The Lean Startup. I'm sorry, the Lean Startup. That's where it comes from. And this idea is make a quick prototype, validate that it will work quickly, and decide quickly if it will fail or pass. And if it's not going to work, move on, do it again, do something else. But the idea is you want to fail fast. Yes. Oh, minimum viable product. Right. Sorry. Yes. Minimum viable product. So, and that's the idea is you want to get something that's minimally viable so that you can actually figure out if there's a there. And I want the customers to succeed. And I know the product feedback is going to be the difference between it succeeding or not. So if you have an MVP, you can put it in front of a customer and you can get early feedback on whether or not that thing's actually going to fly or it'll immediately be discounted. So here's an example, interviewing potential customers. If you don't know your customers, your product is doomed. So, and you can't just take away and interview your friends or family members or people that you think, might be, I'm building a new robot for house cleaning. I can't go to Wayne and say, Wayne, what do you think about my home cleaning robot? Isn't it cool? And then Wayne would be like, oh yeah, I'd buy that in an instant, right? That's not good market research, okay? And in fact, it was a funny joke when we were doing projects for Hasbro. Their marketing teams had a name for this. They called it kitchen table market research. And it was actually a fireable offense for the marketing people there to do this kitchen table market research. If they had a concept for a toy and took it home and showed it to their kids, my kids think it's great. We should make millions of them. You're fired. So number 7, you want to strike the problems fast. You want to define it, gather the solutions, and do some simple upfront work to reduce it. So examples being, I think I actually have a perfect example here. Oh yeah, is this idea of very quickly figuring out where in your process of the product being made, you're going to fail. And the ways that you can do that are coming up with a list of options of, if we have 5 different ways to solve the problem, let's sit down and briefly look at the 5 different ways and look at the cost and the benefits and the trade-offs of doing it that way and what the long-term impact is going to be on the thing that you're actually making. And if you can kind of do that a little bit on the hard stuff, and usually it's the red flag items. It's something like, I'm just think of a good story. Okay, we had a customer which is broke now. So now I don't feel bad telling a story about it. But we had a customer where they made a wearable device that you could wear that would predict asthma attacks by counting how often you were coughing. Okay. And they had an algorithm that they used that was based on some machine learning or something. And we always just kind of trusted that the algorithm was correct. And we didn't really spend any time working on that because it was our job to build the hardware and they were going to put the algorithm in the hardware that we built. Well, when we built the early prototypes, they misbehaved and we couldn't understand why. And then we spent a lot of time wondering. And then finally they showed us some of the way that they did the algorithm. And it was like, oh, dude, this is all got to get fixed. There's no way this is going to work long-term, And if we had not figured out that that was an issue, even though they eventually went broke later, if we had not identified that as an issue early, they could have literally taken the thing out and did a field trial with it and had half of them not work right just because the algorithm was no good. So these are things that we were able to identify early and then bring it up as hey, this is a big red flag. this thing that you're asking us to do, and then be able to prioritize. Let's go solve these problems first. Because if we can't solve these problems, you don't have a product in the end. Don't wait till later on and leave the hard, unsolvable stuff for later to do, because the low-hanging fruit's right there in front of you, and now I can deal with it. So that's the essential idea of this. Okay, the last one is design to scale. Okay, and this is going to be really hard for my fellow homebrew members. Do not use hobby parts in a product that you're actually going to scale. And the thing that I often find is we have customers that come to us with prototype devices where the insides of the devices are a bunch of parts they got off of Adafruit. Okay. And then they think, oh, I could just buy these from Adafruit. I'm like, no, you cannot buy these from Adafruit. You need to. A perfect example that I love is Adafruit sells the NeoPixel. Okay. The NeoPixel is a brand that they gave it. Okay. It is really a world semi-LED, and it's made by this company in China. Those LEDs, they cost 11 cents a piece in volume. Okay. And Adafruit sells you a package of 5 for like $11, I think, or $12, something like that. So know where your parts are coming from, and then looking at the life cycle of where they go, and making sure that you've taken that into consideration when you're designing your thing. And that's one reason a lot of people do hire us. They have things that are made out of hobby parts, and they want to get rid of those hobby parts. And how do you do it? It's not so simple. And then you got to look at where in the life cycle those components are. Are they low cost because they're on clearance, because they're going end of life, or are they low cost because they're actually a low cost component? Or do they come from some weird single source vendor where it's questionable provenance? Maybe it fell off the back of a truck. That's why they're so cheap. And then determining where your products are in the life cycle, and then also having vendor relationships with the part maker. So a lot of times we're lulled into this false sense of security. It used to be actually pre-pandemic. Okay. It used to be you could build a thing and you could just in time assemble it out of DigiKey stock or Mauser stock. But then the supply chain all went to hell in a handbasket. And now you can't do that anymore. You have to know where it is, and can you get it? And is it going to be able to be? So you've got an ST. I got people that'll come to me with an ST microcontroller in a product, and they've never spoken to ST ever about anything. They got no relationship. And now they want to make 50,000 of them with the ST partners. So, or I've got a TI battery charger. I've never spoken to TI. TI has no idea I'm about to release a product that I'm going to ask for 100,000 pieces a year on, and it could totally screw them up because they don't know about it. So build those relationships with the vendors downstream, so then that way you've got it figured out. And then let's see, 9, partner early with a contract manufacturer. This is something that Bob and I did in the early, which was we would have a product that we were working on for Hasbro. They would immediately send the early stuff over to a contract manufacturer in China that was going to be the one that was going to actually build it, so they could get that early build feedback. They could understand what kinds of tooling impacts the plastics had, or what kinds of stuff that had to happen in order to put it together to make it more efficient to put together at a lower cost, at the lower bomb cost. So the idea is they will often have manufacturing optimizations they want to apply to the thing that they're doing. And if you could apply them early in the process, guess what? It's cheaper to make the thing. So the idea is you want to integrate that manufacturing expertise into your product design early. And then this is like more of a local plug, but we do have a manufacturing partner in San Jose called Absolute EMS. We build so much stuff there that they literally have said it when they said at one point, Ted, treat us like we're your own personal factory. And so we do. So usually they've only got 2 SMT lines, but they'll they'll typically shuffle stuff around. If I've got something I got to have happen quick, they'll do all kinds of backbending to accommodate us, because at any given moment, we probably have 4 or 5 different things happening in their factory that we were involved in or are involved in. So that's a local one that we work with for low volume stuff. Versus China, we have a couple in China that we've worked with before. The last one is sell it. Okay, now the reason why this is last is not just because you make it and then you sell it. Okay, in the case of a startup company or somebody that's building a new product, you want to sell it before you actually make it. Okay, but you don't want to do the Elizabeth Holmes version of sell it before you make it. Okay, right? You don't want to fake it till you make it at a level where it's fraud. But it's okay to a certain element of a little bit of fake it till you make it is okay. And most people expect that that's going to happen, but that allows you to gauge market interest in your product. What we did, okay, this is another weird side story, but it's a good one. So when we partnered with MediaTek, one of the things that they told us that they needed us to do was design for them a couple of eval boards that were like Raspberry Pi form factor with their chips on it. And so we did, but then we ran into all kinds of problems of how they were going to distribute these eval boards and how they were going to be able to get their customers dialed up with them. And they had a partnership with Seed Studio in China where we would send Seed Studio the design, they would actually do the build, and then they would put it in their little Seed Studio store and sell it. Well, the problem was is all sourced out of China, and they were not really urgent in like getting the store replenished when they would run out. So they would go for months without stock and nobody could buy the eval board. And finally I just got tired of it and said, forget it. We'll just stand up a little Shopify store. We'll put the boards in there. We'll make them to order. We'll make a couple hundred of them at a time and then we'll stock them. And then when you go online, you got to buy it and you click buy and you get it immediately. And there's none of this, oh, you're going to wait a month to get it because it's not in stock. So so that's an example of, selling it. I like my Elizabeth Holmes example better. But let's see. So this is kind of the summary of our 10 steps and that we do. And you'll constantly see if there's a customer that's, in our case, if there's a customer that's kind of not doing one of these things in their pipe, I'll be over there like going, so what are you doing to pre-sell it? Or so you have a contract manufacturer in mind that you're thinking about using? These will be things that you'll see me in there like trying to promote. And that is it. So that's really it. Oh, does it not working so good? Oh yeah. That's kind of it. But I can also tell all kinds of crazy stories about weird crap that we worked on. Go ahead. Oh yeah. So he's asking, what's the minimum budget that you have to show up at my door before I say get out of here? And that number used to be a lot lower years ago. It's a lot higher now. Typically, it's usually between $50,000 and $250,000 to kind of get something reasonable moving out into the market. It's a lot of money to basically tool up a hardware product and actually get it out. It's one thing to build prototypes. It's another thing to build a product. So we still are pretty startup friendly, but for like the 2-person startup in their garage, which is still really early days, and they're still trying to hash out their MVP and figure it out on their own. Usually I don't recommend, I usually try to like say, hey, look, you need to get further along. You need to have more money before you come to me. And then usually I give them a lot of good advice and I say, hey, go away for a while, then come back later on when you're further along. So that's the typical spiel I give these days. So the question is, how long do our development projects usually last to build a robot? So if we're talking big, like Ross mobile robot, which is like, I'm assuming that's right, versus consumer goes faster because it's usually less complicated. But then the consumer ones have problems where they need to do big volume in order to be very successful. So big mobile robots, usually 6 months to a year is kind of pretty typical. We've done some ones where the customer was pretty far along with a prototype before we got involved. So then the amount of time it took to get them to something that was manufacturable was less. We're doing a pretty high profile one now that I think we've been on it for 6-8 months, but they already had a working prototype before we arrived. We just went in and optimized the whole inside of it and made it more production grade so they could make many of them. Typically with large mobile robots too, a big element in play with these things is the wiring harness is complicated. And you end up needing a really awesome cabling contractor. And one of the things that we are very good at is building a cabling spec. So like you might have a robot that's got 50 cable harnesses inside of it to do some complex thing. And we'll come in, we'll design the whole harness, and then we'll be able to hand it off to the CM to actually make the larger volume of them. So that's how one of those DFM things that we do really well. I've literally got somebody that I think she wishes that this wasn't the thing that we primarily leaned on her for, but she does most of the cable harness work and does a really good job of it. Yes.
Do you get involved much in projects? I've noticed that a lot of things, or a number of things that I've had in the past few years have been actually, the design is almost pretty much done, and it looks like they're actually, what they're doing is just raising money to get the build, like to send over to the CM and to fund them to do it. But
Right.
almost like done.
Yeah, those are the ones. Okay, so the question is talking about crowdfunding projects and how far along do people have to be for Kickstarter or these other crowdfunding platforms. And Steve has noticed a trend in the last year or two that the crowdfunding campaigns seem to be people just showing up with the whole thing's done. There's not really any more work to be done. It's just kind of like taking an order pretty much. And it feels like that. And it used to be that people did show up with pre-made stuff but in those cases, it was a lot of fake it till you make it, right? And a bunch of the fake it till you make it types went broke, right? And then there's the one on the list. There was this one on the list about the smart speaker. What was that thing called? Sherlock Holmes's brother.
Watson.
Moriarty. No, Mycroft, right? Mycroft. Okay, so like, it's a bummer that thing never made it out because it looked really cool and they had a lot of really great software, and it looked like they just kind of failed on the hardware end of it. They did get embroiled in some legal stuff too, which is really unfortunate. Right.
No, we're not going to fund this, and no, we're not going to do this product line, but go off and do it, and if you can get people to give you $2 million, then great.
Yes, hold on, I'm gonna back up here. Hold on, I'll back up. Yeah, no, so I'll show you, there's a product in here. I think there's more than one product that was us crowdfunding. Keep going. Yeah, Dot and Dash. So the Dot and Dash robot we worked on a number of years ago. And I have a good laughs about this one. Hold on, I'm just trying to get the PowerPoint to catch up here. One more. No, one more. Come on. Okay. So this little blue robot, Dot and Dash, those were designed to teach programming to kids. And the idea was you have a Blockly-like programming language on like an iPad, and you write Blockly-like code, and you make the little dot and dash robots do things based on your Blockly-like code. And they've actually been quite successful in selling into education, but that wasn't originally, they knew they wanted to eventually go there, but everyone knows selling into education is super hard. So you got to sell it to consumers first. So this thing, if you, and you can kind of see in our photo here, but if you go online and you look at photographs of Dash, there are photographs online where his wheels are black and not blue. Now, in the case of this one, his wheels are blue. But if you go online, the little wheel treads have black wheels. Those were prototypes, and they were handmade, and they had only 5 of them. And they were made at a local model shop down here in San Jose. And they ran a crowdfunding campaign where they pre-sold 15,000, 20,000 robots, okay, before they tooled up the manufacturer and made it go. And it was definitely run old school, you know, we're going to build it, we're going to run a crowdfunding campaign, and then we're going to build it. The product design was not complete when they ran the crowdfunding campaign. So there are still people that do that, and they can be wildly successful, but it only works if you can sell tens of thousands of them in your crowdfunding campaign. The ones that are the highly suspect ones are the ones where their goal is set really low, and yet the product itself is looks super complete and looks very ambitious. Those are the ones that, those are the ones that are the problem. But it's become more and more of a thing of like, we're just going to use crowdfunding platforms as a sales channel. And but there are still people that pull it off. It's just a small number. And but I was really pleased. Oh, and that's another thing too. The VP of marketing for that company used to be like the VP of marketing for some online insurance company. So he was a brilliant online marketeer. And so he knew how to get all the buzz around it and how get all of the media all lathered up before they were going to release it. And so it is possible. It's just really, really super hard to do a crowdfunding campaign and pull it off and actually turn it into a business after you're done with it. So. Yeah. Right. Okay. So this is a really important question. So he's asking about B2B products and how much does industrial design matter? And, you know, is what it looks like versus what it does, what's more important? And the reality is, for somebody that's never seen it go, what it looks like is really super important, because it's got to look like it's going to do the job that you're claiming that it's going to do. So it's funny actually, because Dusty hired us to do a lot of industrial design on the product before it was ever completed, that they used in their pitch decks and in their online marketing prior to them building what they've got now. Okay. And the thing that we built or designed, it looks like a power tool. Okay. It looks like something that belongs on a job site. And it's interesting now, like if you look at what it looks like, it still looks like it belongs on a job site. It looks rugged. It looks a lot less like a power tool. But the reason why they can get away with this now in this is because they've shown so many people how well it works. It's literally less of what does it look like and more of, oh, I know exactly what it does. The question is, how good does it do it? And it's funny, actually, you can see like Hewlett Packard is trying to compete with Dusty now. They've built a job site layout robot, and they're back where Dusty used to be, where it mattered what it looked like, because what it looked like mattered more than how it could actually do the job, right? Dusty's does the job so well now, it doesn't matter. It matters less how good it looks. But if it looks bad and it doesn't do the job, that's a problem. Right.
What's the delta between when you manufacture or how old you get, or maybe how the difference?
So big mobile robots, the biggest problem with, okay, so the question back, like go back to the question. The question was, how much BOM cost reduction can you do? And how do you get the cost out of the product that you're building? And the answer is volume. Okay. And the biggest problem with large mobile robot projects is usually in the first year or two, you're never making more than 100 of them at the most. If you're lucky, you're making dozens of them. And so the problem that you generally run into is that you can't really ever get the cost out of the BOM until you're way down the path. You just need to make sure that the plan that you've got for how you're going to get the cost out of the BOM is baked in. Okay. So one of the things that bothered me, and I don't have it up here, but we worked on the Jibo. Okay. And if you're familiar with the Jibo robot, it's like a little home assistant robot that came out. It actually was released or demonstrated, and they did their Kickstarter campaign 2 years before the Amazon Echo. What? Yeah. Okay. You worked at Jibo. Great. Okay. So an example in the case of Jibo that, and this is why I use this as an example on the thing, the inside of the product, they had a Tegra in there. Okay. And one of the warnings that I'd given them early on was like, if you put a Tegra in there and the software developers are used to driving a Lamborghini, they're never going to want to drive a Toyota later on down the road. So don't do that. But they did it anyway. So, but that's another important aspect to bring into the puzzle is that when you're doing a product design for a mobile robot, you don't want to give your software developers a Lamborghini. So you do want to kind of like build in, don't over engineer the compute stack on it at a level where you will become so reliant on it that you'll never get rid of it. Right. So that's a really important point.
Got a question online here when you get a chance.
Okay, hold on 1 second.
People that work in academia and they decide that they're going to like turn their PhD into something.
Right.
Coming out of an environment where they're used to infinite storage over infinite bandwidth for life for free, that was in their lab.
Right.
And now suddenly.
Yes, projects that come out of academia. So Steve is talking about academic projects that are turning into products. And we do encounter a lot of those projects where they've got a project, they did it as their PhD thesis, and then they have a hard time swallowing the move to the outside world to turn it into a product. One example of one of those, though, that was crowdfunded and did do it, and we worked on it, was the Kamigami. It was like this little bug-inspired robot. It was a bunch of guys up at Cal Berkeley that had done animal-inspired robots. Okay, we did the electronics package in that thing, and then we spent a lot of time with them educating on how to make it cheap so that they can make it. Right, that's right. Yeah, Andrew Gillies, yeah. Yeah, he's cool. Okay, there's an online question. Go ahead, Camp.
Yeah, Gopi's asking if you'd speak about the Cellbot project that you've worked on and where's that project at?
Okay, so way back, we worked on we had an early project that we had done with Hasbro where they wanted to basically build a little gizmo. You could snap a cell phone into it and it would turn it into a robot. And we did a kind of a three-way partnership with Hasbro and with Google. And Google had their Cellbots projects, and we were trying to like three-way it between the three organizations. And then ultimately, Google built prototypes of the robots. And then we took those prototypes when Hasbro abandoned the project and decided they didn't want to pursue it anymore. Google kind of sidelined it because it wasn't really that interesting to them anymore. And then we tried to see if we could run a Kickstarter campaign to turn it into a product that you could sell, that we would do ourselves. And we called the thing the Oddworks. And we tried to raise $60,000 on Kickstarter and we didn't meet the goal. And I'm really glad we didn't meet the goal, because then we would have actually had to make it. And it was too darn close. Like if it had been wildly successful, we would have made it. But we abandoned it because there wasn't enough interest in it. We weren't able to generate enough interest in it. So it's projects like that that make me say, I'm really good at selling consulting services. I'm not really good at selling end products. So yeah. There was another
Yeah,
question.
well, that was an interesting project though, because I always felt there's a life of a cell phone post this, end of life. And I thought, robots are great. You can use cell phones to kind of power them. But unfortunately, I don't know. I don't see a market for these things. Yes.
Right. I mean, they're cool for the hobbyists, but there's just not enough hobbyists in the world that want them. So, Ralph.
Ted, I have a question about the Dusty robot. You're saying that the robot could go on the floor before people. That
Yeah.
robot must weigh 100 pounds. What is it about people walking versus the robot driving around?
Oh, it doesn't weigh 100 pounds. You could pick it up.
Okay, and so a person with their weight would imprint on the floor.
Yeah, that's right.
Whereas the robot doesn't.
Correct.
Okay, I assume they design their tires or something to minimize that effect also.
Yeah. So yeah, that's
So I did a search. I see the Star Wars Use the Force trainer. There's one
Yes.
available on Amazon for $250.
Really? It's like a collector's item? That's
Yeah.
awesome.
Well, that was
I
an
think
awesome product. I loved it.
You guys, I have a couple. I should go put them on eBay for $250. Yeah. Really? Yeah, we still have one in our lobby. We periodically fire it up and like make it go. And yeah, it's really cool. Yeah, I spent, I don't know, a couple weeks sitting in a Chinese factory debugging the firmware on that thing. It was pretty brutal.
Do you use the Force?
I needed the Force. Yeah. I needed the Force.
I got one more question about hobby parts. What if you're building a hobby product?
Oh, then it's great. So like the NVIDIA Kaya robot is a total hobby project part thing. And the thing's totally open source. You want to build a nano robot, you can go online, get all of the 3D parts, print them yourself, and buy all the parts online and make a robot.
Very fun.
But it's kind of like, that's not really a product that you would sell. It's more of like an open source, hobbyist thing. So Ralph, did you actually have a question? Oh, right. So yeah, so Ralph has a pet peeve about academics building robots for commercial purposes, where frequently they say all the math is going to work out perfect. I've proven this thing's going to work perfect, but then the face of reality comes into play of the real world, and then it all falls apart. Yes, Tony. Yeah, so Tony says avoid Android and commercial robot projects. Right. Oh, right. 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 Got it. So that was a very long comment by Tony, but I will summarize that he says lots of academic papers have elements in them that are left up as an exercise to the reader to solve. And it turns out that in many cases, those are intractable in the real world. Okay, any other questions before I hold up my laptop?
Robots up there, you know, like the night scope and the Dusty, how much of the actual product that your team developed versus their team, like handed over and then they carry it forward?
So
They all have engineering.
they do. And usually it's a piece of it. And usually the piece that we focused on was the electronics and the firmware. So usually like there's a set of boards in there that drive all the power systems and drive all the cameras and all the battery management. And in many cases, there's a motor controller. So like in the case of the Bear robot, we did power management, battery management, all the docking, all of the base low level control, a lot of the Ross early stack work. We did, and then in that case of that one, they didn't want to buy off the shelf brushless motor controllers because they were going to make thousands and thousands of robots, and the cost of these and that volume is very expensive. So we designed them a custom brushless motor controller from the ground up that they're using, you know, again, to save money on BOM cost and whatnot. So, so that also comes back to your other BOM cost thing about picking your battles on specific things. Like in that case, they picked their battle because they knew they were going to make thousands of robots, and they knew nobody made a good BLDC motor controller for less than about $500. And they were like, oh, you know, it could be made for less than $50 worth of parts. It's just an issue of having a design that you can own. So that we ended up building a design, then they own it. So, oh, that's one other item too, quickie side. We treat our customers, we're like hired mercenaries. So we don't like try to actually own their product. And some people, a common question people will ask is like, oh, do you ever work for like shares in their company? Why didn't you get a piece of the action? And the joke of that is there's a guy, Mike Thompson, who works at Dusty, used to work for me. But his big joke was he's like, well, I can't really go home to my wife and say, well, I didn't get paid this month, but I got these magic beans, you know? So that's kind of, he would call those magic beans projects. And we don't do it because 19 out of 20 times you get burned, and then, you know, it's not a profitable way to operate. So anything else? Last, Tony? He says, populate what was that? To paraphrase a song, you'll never get royalties, 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 royalties. Okay, I think that's it. Oh, Ralph's got one more comment. Right. 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 So Ralph made 2 points. One was when you're building a robot company, it should never be all about the robot. It should be all about the solution that you're delivering, and the robot just happens to be a component of that solution. And then the second one he said was, oh yeah, make sure you have your own team. So you could come to us and have us design you an amazing robot, but if you don't have a giant team of software engineers to carry it forward and take it to market, then it's kind of DOA. So it's important. Software engineering and robotics on these larger robot systems, the software is the long pole in the tent. And building the hardware and building the mechanical pieces, that's really easy compared to the long-term care and feeding for some massive software environment for a larger solution that you're providing. Okay. Oh, yes. They do. Yeah, so they do. So he says a lot of these robots, do they actually use ROS inside? And it turns out that was one of the ways that we got kind of going on the mobile robots was we had done some Ross Robotics early. And then when all of the Willow Garage people left Willow, they wanted other people who knew Ross Robotics to help them. So Relay Robotics runs Ross. Bear Robotics runs Ross. Nightscope runs Ross. Cobalt runs Ross. Simbi runs Ross. Dusty does not run Ross. At least I don't think. Maybe they do. I don't know. But most of them do. All the big mobile ones that we've worked on run Ross, and that's one of the reasons why they're coming to us. Correct. Consumer related ones, no. Although Project Tango had a bunch of Rossi pieces in it, because they hired at Google when they were doing Project Tango, they hired a bunch of ex-Willow people to help them with the mapping. Yeah. Online comment. There was a question. Comment online.
What's the supply chain issue of Raspberry Pi and NVIDIA Jetson affect the product development?
Right. So the Raspberry Pi supply chain thing is only an issue for hobbyists. If you're in direct contact with the Raspberry Pi Foundation, you can get Raspberry Pis.
Don't use hobbyist parts, right?
Yes. Jetsons. If you're using Orin, they're gettable. If you're using Xavier, they aren't. So if you're thinking about doing something with Jetson, use Orin. That's the solution to being able to get it. But everybody that just spent 6 months working on Xavier 6 months ago, they're hosed until they get their stuff back. Well, that's another interesting point on NVIDIA. The SOMs are buyable, but the carrier boards are the problem. So the reason why the dev kits you can't buy, but you could go and buy a carrier board and buy a SOM and then get the equivalent of a dev kit. But it's a lot more expensive because it's not subsidized by NVIDIA. Right. So is that it? All right. One last one? No? Yeah. It is, but then make sure you have a path to undo it. And a lot of places, they over-engineer it with no path out. And then it's like, once it's in there, it's never going away. Okay, Wayne?
Okay, I want to thank our speaker, Ted, for an enjoyable talk. Okay, and we're going to start wrapping up here. I'm going to let Camp do the final wrap up here, and then what we're going to do is we're going to break up and just talk with one another.
Yeah, I wanted to announce that we have an open board.
Okay, I mean, yeah, correct. Dan, our secretary treasurer, we have an open board seat now for Sergeant of Arms. Chris Meyer had to step down from that position. So what?
For our local people here, there's lots of free stuff on the table back there. Take a look. If you don't understand what the stuff is, take it home and look it up.
Okay, with that, please take over, Camp. Thank you.
All right, we've got, thank you very much, Ted. That was awesome. We've got the HPRC business meeting next Wednesday on March the 1st. And then March is our phase 1 challenge month. So I'm going to be bugging you all month long to get your robot off the shelf, dust it off, charge it up, fix it, make it better. And everybody's going to be showing up with a homebrewed robot next month. Everybody knows where the mailing list also. That's where all the news is. Thank you very much, Ted. Have a good evening and keep building those homebrewed robots.